Hello, I'm Canchen. I'm one of the lead CAs, and today we'll be going over compound data types. As an overview of what we'll talk about today, first we'll look at some different compound data types. The most primitive compound data types are tuples and arrays. We'll talk about vectors, which are a common type of collection, and then we'll look at two special enums, option and result. For some additional reading, you can look at these two chapters of the Rust book, which go over similar content as this lecture. As a recap from last time, Rust has four primary scalar types: integers, floats, booleans, and characters. These scalar types can each hold one value. But today we'll be looking at compound types that are made up of many of these scalar types and group them together into a single value, and these compound types are able to hold multiple different values. The first compound type we'll look at are tuples, which are basically groupings of values. And the key thing to know about tuples is that the values it holds can be of different types. In this case, if you look at tuple 1, it contains an int, a float, and a string. And the other thing to note is that tuples have a fixed length, so once they're declared, we cannot change the length of the tuple. Because of this, at compile time, the compiler will know that this tuple, its type is a tuple of an int, a float, and a string, and has fixed length of 3. This is why we do not need to provide an explicit type annotation, and the compiler is able to figure it out. However, if we did want to provide a type annotation, we can also choose to do that. There are two main ways of accessing tuple values. One is through destructuring, where in this case we just assign tuple 1 to x, y, and z. And since tuple 1 has 3 values, it'll map x to 5, y to 3.0, and z to chicken. This only works if the number of variables here is the same as the length of the tuple. So in this case, y would get assigned 3, and this would print that y is 3.0. The other way is to use indexing. Tuples are 0 indexed, so this tuple 1.0 would refer to the first element in the tuple, which is 5. Similarly, word gets assigned to chicken, which is the third element in the tuple. A special tuple is the unit tuple, which doesn't contain any values and kind of has 0 length. And this is typically used to represent the empty value or an empty return type like null, but we'll go over some better ways to do this later on in the lecture. The next primitive data type we're looking at is arrays. These are similar to tuples in that they have a fixed length. However, the difference is that in an array, all the elements must have the same type. So here we go over some ways to declare and initialize an array. So here we could just have a list of values, and the compiler would deduce that this is an array of ints with length 5. We could also provide an explicit type annotation, where we have the type, so characters, a semicolon, and then how many of that type we have. So this is an array of length 3 of characters. Or we could, instead of specifying each of the elements individually, we can use repetition. So this is 4 trues. And because true is a boolean, the compiler is able to deduce that array 3 is an array of 4 bools. In order to access values from an array, we could also use indexing. And this works similarly to array indexing in a lot of other languages. And another thing to note is that array indexing is also 0 based. So number 1 is assigned to 1, and number 2 is assigned to 2. Now we'll be talking about vectors. Vectors are a collection type in Rust, and they work like an array that can be resized. And why this is the case is because under the hood, the vector stores its array on the heap instead of the stack. And similarly to arrays, all elements of the vector need to be the same type. In order to initialize a vector, we have 3 main ways. One is to use vecnew, which creates a completely empty vector. However, because the vector is empty, the compiler does not know what type the vector is supposed to hold. And we must explicitly provide this type annotation, telling it that this vector is supposed to hold I32s in this case. The other option is we can use vec_from and pass in an array, and this will initialize the vector with the elements in the array. So in this case, we would get a vector that's filled with characters. Our third option is to use a macro. Macros work basically like functions, except they're evaluated before your code gets compiled. So in this case, writing vec, this exclamation mark signifies that it's a macro, and passing in this array would be similar to writing vec from and then passing in this array, except that this code is shorter and easier to write. In both cases, for either using vec from or the macro, the compiler can infer the type, so we don't need to specify it explicitly. To insert into a vector, we can use the push function, which will add an element to the back of the vector. In this case, so we'd start off with an empty vector. We'd add 5, so now the vector contains just the element 5. And then we'd add 7, so now the vector contains 5, 7. And then we would print it. That's what we should expect. In order to access individual elements, we can use indexing like arrays. In this case, vectors are also 0 indexed, so once we add 5 and 6 to the vector, when we get the 0th element, it should be 5. However, one thing to be careful of is that if we pass in an index that is out of bounds, the code will panic and we will crash. So in order to get around this, we'll have to talk about the option struct. The option enum, excuse me. So option is a special type where it can be either one of two variants. It's either none, which means that there's no value associated with it, or some, which is associated with some value. So you can think of some as wrapping some value inside of it. This t signifies that it's a generic function, a generic enum, so this t could be any type. For example, if we had an option I32, it would either be none, or it would be some and then an integer, so maybe 5. In order to get this integer out of the option, we can use the unwrap method, which would take the element out of some. Or if it was none, it would crash. We'll talk about some better ways to handle this in future lectures that won't crash when the option is none. So now we can talk about the get and pop methods. So if we use the get method instead of using indexing, it works similarly in that it'll get the element at the 0th index. However, if it was out of bounds, it wouldn't crash. It will simply return none. So get would normally return an option. If some element does exist, it will return some and that value, or it will return none if it is out of bounds. Similarly, the pop method removes the last element from the vector and returns it, again as an option. We also have some choices for how to iterate through a vector. One is we can simply iterate through the indexes, like a normal for loop, and then use get to get the values from the vector. Or we can use a for each loop, where we first convert the vector into an iterator and then iterate through that. This will give you access to references of each element inside the vector. Another enum that we'll look at is the result enum, and this is typically used to return a value from functions that could also potentially return an error. So again, result can be one of two types, where it's either okay and it has an associated value, or it's error and it contains the error from the function. So in this case, if a function were to panic, it could just return this error instead. And this would allow the function that called it to handle this error potentially instead of having the code crash. As a recap of what we covered today, we talked about a few compound data types like tuples and arrays. We looked at vectors, how we can initialize them with vecnew or the vec macro, how we can add elements using push, and how we can access elements using indexing or get and pop. Finally, we looked at two different special enums, option and results, where options are used to represent none types like nulls, and results are able to represent error values from functions. For some important announcements, Homework 1 was released last week on Tuesday, and it is due tonight by 11:59. Homework 2 is going to be released today, and it will be due exactly a week from now. And then we will be releasing MP0 tomorrow, so keep an eye out for that. Thanks for listening.